So, very warm welcome here to the Parker booth at Bauma 2025. Parker Hannifin is proud to be the global leader in motion and control technologies. And here at Bauma, the motto is technology inside that moves your world. And that world is the world of these giant machines for construction and mining that you see outside. And here, Parker is the hidden champion with the technology inside, helping customers to fulfill their engineering dreams for mobile machinery and off-road applications. Here at the theatre, it is our final talk of the day. We have gathered experts from all over the globe to share their insights on the four main themes that we see driving the industry. And those are the themes that you can see here at the booth: digitalization, electrification, mobile hydraulics, and clean tech. Up next, we're going to be examining the role of control software and what that means for OEM manufacturers, for your productivity, for safety and cybersecurity aspects that you need to consider, and also new standards coming up that you need to be aware of and implement. So it's my pleasure to introduce our experts and come over to you, gentlemen. All the way from our electronics expert, originally from the US, but now in the UK, where he's part of the Parker Mobile Growth Team, and he manages the application engineering team in the electronics controls division. So your job title is actually the second one on the on the slide that was switched over. He is delighted to be back at Bauma after 20 years. Is that right, Jason?
Yeah, that's right. It's been a long time since I've been here. A lot has changed, but a lot is the same. So it's quite tired, exhausted, but ready to go for today.
Fantastic. And you said you're also really excited to see how actually software has come into the forefront here at Bauma in the 20 years, right?
Yeah, that's right. I mean, you can see the sort of technology advancements that have happened, and a lot of them are down to software changes in the world. And it's great for, as an electronics engineer, as a software developer, to see software taking the forefront finally after all these years.
Fantastic. We'll dive in. So this is Jason Gilmore. Very well. Warm welcome to you, Jason. And joining us as well, our next expert is also an application engineer for mobile systems based in Germany with an in-depth market knowledge of agriculture and forestry. Is that right, Frank?
Yes, but additionally also construction, material handling, and let's say all other stuff that is driving and walking.
Okay, I've experienced with you. You like pushing the technological frontier together with customers with technologies like steer-by-wire or hybrid powertrain systems.
Exactly.
Herzlich willkommen, Damian Frankiewicz. So, Damian, let's get warmed up. In a nutshell, in a sentence, let's say, what can we expect from this live talk? What can our audience expect to take away from this live talk?
Well, we can expect that I will explain to the audience, especially the importance of software technology nowadays and the possibilities to increase efficiency, safety, and different other aspects on the machine by just software development additionally on, because the base is already there. And I have seen on several booths during my days here that the software impact on the machine is getting more and more, and also with new challenges and expectations.
Okay, so we've got the words software, safety, cybersecurity. They all sound fairly similar. Can you tell us what the differences really are?
Yeah, well, first I would say we need to divide the software approaches a bit more. So you have, for example, assistance systems that are just supporting you in a certain role, keeping some values on the machine steady. And it's a bit like development with the same originate. So, for example, if you have an assistance system, you could improve it to an automated system. And later on, maybe also to have an autonomous machine that is quite familiar in the in the agriculture market, if you know self-operating tractors, for example. And one important thing is to have a straight difference, or let's say putting a border between these three types of software, because this is where the software starts to be developed. And for example, there is this SAE J3016 norm standard that tells you, for example, when do you have an automated system? Well, you're still driving when the features are operating. So, for example, you're driving with a reloader and you have some brake assistance systems or something like that, then it's automated. But if you go into the autonomous functions, then the declaration is you're not driving anymore. That means you're not sitting on the machine. The machine is completely doing it itself. And if you look on the slide, you see that coming back to safety and security, the effort and the demand for a much more safer system comes with the increase of the software going more into autonomous functions.
Okay, zooming in on the automated control, can you give us the 3 key features of successful automated control?
Well, at the beginning, the success, or let's say we should start at the beginning with really understand what is the machine doing, and especially what the customer is expecting from the application. So you really need to have a precise description what the machine should do. The background is because the machine will do it himself. And you don't have to go any risk that the machine is doing something else because you missed something or the definition of the function was not properly involved in the list of requirements or stuff like this. The second one is to find the suitable technology, like sensors, for example. You're replacing the operator, you need to consider that the machine has to get some environmental contact, for example, cameras, GPS antennas, or anything else that tells the machine where are you, what are you doing, and what should you do. That is the second part. And the third part is the virtual world. So creating a software with all demands, especially on safety and cybersecurity, to keep this machine steady and safe.
Thank you for that overview. If I'm working towards automated or autonomous machines, what is my primary motivation to do that? Is it just to dismiss employees, or
I
are there
wouldn't
further
say
benefits?
it's dismissing employees. It's a fact that skilled labor is more and more getting shorter, or we have a shortage regarding skilled laborers. So I would say it's more putting the employee to some other roles. So, for example, you can operate things that are much more efficient when the machine can do it its own. So you're looking for processes, for programs, for commands, for example, that the machine can take it himself much more care and do it much more precise than the operator is doing.
Can you give us some examples of that?
An example could be, for example, if you have a reloader and on this one, and you have, for example, the operation that you need to load, for example, a truck or something like this, you could do it automated like here. So at the beginning, you need to consider, like I said, what the machine should really do. The second point is to find proper additional components. For example, when you don't have an operator anymore, there's nobody that can push a pedal and nobody that can push a joystick or something like this. So you need to be sure that you have electronic architecture that can give the controls themselves. So as an example, a steer-by-wire, brake-by-wire valve to make the machine more independent.
A steer-by-wire, sorry, I missed
A steer-by-wire and a brake-by-wire valve, for example.
and brake-by-wire,
So
okay.
you get in more electronically commands.
Okay.
Then, of course, the main target is the software. So this is where the key for success is hidden because, electronics are well known on the construction or mobile machinery for a very long time. But the creation of the suitable software, this is the key for success. And like I said, if you, for example, on this picture, you're going on a automated function, you get some additional sensors. The machine has a proximity distance, for example, knows when to stop or knows when to tilt the bucket. If you go on the automated solution, then you have much more effort on the software. First, to make it safer, like, for example, a geofencing, that you tell the machine you should not cross this area because otherwise it could be dangerous. But also additional sensors to tell the machine, look, there is a pedestrian, look, the truck is standing there. And with the GPS antenna, the machine knows exactly where it should be.
You've got another example here of agriculture. Is that also a key area where automation is?
It is a key area. Unfortunately, I didn't find a suitable picture for the construction market, so I had to use it. But it's the target. For example, it's famous for a long time that you have lane controls, that you have GPS-based controls when you're working on your fields. And something similar could be, for example, used for a pave maker on the road or a compactor or something else that has to have some precise operations in one lane, for example.
And perhaps longer shifts as well, something that uses longer shifts?
Yeah, of course. Theoretically, if you don't have a driver or an operator anymore, the machine can operate as long as it needs to. So
Okay, thank you for that overview, Damian. What about software development processes, Jason? How will the software development process be affected?
Well, I think really software is going to move a little bit more from what's now traditionally much more linear process to a much more iterative process with a much more uh, involvement in from start to finish, where we're trying to develop something, then we're learning more, then we're redeveloping, we're re-releasing software. So the development needs to take into account the operations. It needs to take into account the cybersecurity. And so that means that we're doing a lot more iterative development. We're releasing software more often. And that's somewhat of a change for many companies because traditionally software is done in a very controlled process. And as we move forward, people are going to need to learn how to release software more quickly, and they're going to have the systems that allow them to do that.
Okay, if you take us through this process, where's the starting point and
So I guess at the beginning we're starting with what we would call from a cybersecurity standpoint, anyways. We're talking about a TARA, and a TARA is a threat assessment and remediation and assessment. So that we're looking at what are the areas where we could be attacked, what are the vulnerabilities, and what can we do to address those vulnerabilities. It's similar to an FMEA that's used in a mechanical processes that people would be familiar with. And the idea is to quantify the risk, look at what we can do to mitigate that risk, and then define requirements that allow us to drive the software to address those risks in a way which considers the most severe issues first. So very similar to a traditional FMEA.
Okay, so that TAR is the first step, and then
The TAR is the first step. Once we finish the TAR, I think that's what's going to drive the requirements analysis. And then once we're into the requirements, we're starting to do our design work. And within the design environment, we have many controls that we need to put in place for cybersecurity. So we would be looking at secure coding practices. We would be looking at design reviews that involve people who are familiar with cybersecurity. We would be looking at using code signing to protect the code from inadvertent access, and we would be using many tools that are considering the software development from a cybersecurity standpoint that maybe before we didn't have to worry about. There's much more attack areas with the increased digitalization of machines. So an autonomous machine, those machines have much more exposure to the outside world, and the consequences of issues with those machines are much more severe because there's no operator there to make a decision to stop the machine. So we have to spend a lot more time developing the software requirements around what are the vulnerabilities and ensuring that we address those.
okay, did you want to add something?
yes, it's a similar approach because we are now talking about cybersecurity, but as the functional safety of the software at all. Because that example, I create a function that the machine should do an operation autonomously, it doesn't matter. But for example, what happens if this function cannot be completed? Should the machine go into a safe state? Should it stop completely? Should it do it anyway? And stuff like this. And this is the same approach. So this infinite circle always combines everything what you are doing with the software. So starting by developing the function itself, adding this as a safety function or modifying it towards a safety function, plus considering the cybersecurity feature. And if you change one more small thing in the software or even in the hardware, you have an obsolete controller, for example, a new generation is approaching. You start maybe not almost at the beginning, but you need to consider every step one again. There is no shortcut in between. It could be dangerous because you miss something and then you could have big troubles.
But what about the balance between uptime, the duty cycle operations, and the security considerations? Because those people who are in operations, they want their machines running and say, oh, too much security here.
Yeah, I think one of the things with the cybersecurity is it needs to be invisible because the operators do not want their machines to be affected in their usual performance. They're used to a certain efficiency for those machines, and we can't say to them, your machine is going to be less reliable because we've added cybersecurity protection. So the cybersecurity protection really needs to be an invisible feature for them. Maybe it has a big effect on the OEM and what their process is, but really from an operator perspective, they shouldn't see this at all.
Okay. And the main point of entry is usually human error for cyber threats. Is that your experience as well?
I think I would say that's probably where the most severe consequences tend to happen, is if there's somebody who is trying to do damage, and or if somebody makes an operator error. So I know there have been things that have happened where machines are shut down remotely, especially now with sort of telematics systems that are enabling remote communication. It's very easy to turn a small problem into a major problem because software releases maybe are done remotely, they're done in an automated fashion. So you have to be very careful that you don't turn an operator error into a fleet error with your machine. So you need to be very careful.
Okay, thank you for these examples. What about standards? There's a new standard coming up that you wanted to mention, and what effect does that have on the electronic system design?
Yeah, so there's a couple of standards that are being released shortly. The UNEC R155, which discusses cybersecurity, and 156, which discusses the software update systems required. And both of those will have a significant impact on how OEMs develop software and how suppliers like Parker develop software. So we are in the process of developing our cybersecurity management system, which will involve not just development processes, but also organizational processes, as well as incident response processes that if we do see cybersecurity attacks or if we do have an incident, that is fed back into the system, into the infinite loop of redesign, and we would address those. But we need to consider it from the start, and we need to consider it from an organizational standpoint. Whereas before, development could happen in isolation, it's not necessarily as easy to do that with cybersecurity because there are so many external factors that feed in during the operational and field service aspects of the design. So we do need to take that into account in our processes.
Okay.
It's like a gearbox also that, I mean, if you're developing a software for a machine, you can just start to, for example, creating the software, then considering the safety functions of the machine, creating that, and then creating the cybersecurity. Because it could happen that you figure out, well, it's a totally mistake what I'm creating, it's not safe. You start from the beginning. So all these three parts of software development, if you like to say it that way, so the application, the safety, and the security always stick together, like in a gearbox. So every time you do something, you need also to consider the two other parts involving into this.
Is this part of the Cyber Resilience Act?
That's right. Yeah, that's what the UNEC regulations are preparing you for. So the R155 is the cyber resiliency part of the Cyber Resiliency Act. So these would be mandated standards.
Okay, and when do OEMs need to be ready for this?
It's very soon. It's probably too soon. So I think we're behind already, and I think OEMs need to start thinking about it. You'll see a little bit about cybersecurity here, but there's much to do in the short time we have to do it.
What impacts does that have for the OEMs, these new cybersecurity standards?
Well, there's a number of impacts, but one of the biggest ones that we foresee is related to the UNEC 156, which is around the software update management systems. So what that means is that each OEM has to have a system for releasing new software that's controlled and is resilient to cybersecurity attacks. So in a complex system like the one shown on the screen, we have many input areas where they could be looking to update software that could be done remotely over the air, that could be done locally with a PC tool, or that may be done with a mobile phone or a mobile tablet device. All of those really are areas where they're going to be, the suppliers are going to need to develop those systems. But at the same time, they're going to need to start to look at all of the attack possibilities in these areas, because all of those are vulnerable. And that's really where we're looking to use things like user management, user access management in the protocols that we use. And we are using industry standard protocols that are field proven and accepted within the industry for security of communications. And we will continue to enhance those. And we provide a number of products, which we'll be more than happy to talk to you about in the digitization area of the booth. So if you're interested in discussing these, we're more than happy to talk about it.
Is there one particular product you'd like to highlight?
I think the one that probably is the most interesting from a cybersecurity standpoint is the IoT and gateway devices that we offer. Both of those products really are at the core of the cybersecurity because of the touch points they have. Those allow external access to the machine. So those are where the most significant risks exist, but also the most significant benefits.
Okay. Let's have a question for the audience. Have you ever experienced a cyber attack in any form? Oh, I see some raise of hands over there. What about you, Jason and Damian?
Yeah.
Can you describe your experience with a cyber
I had
attack?
once an adventure, but it was my fault because the target was to just update a software on a subsystem on a machine, and I just took out the wrong pinning of the CAN bus. So I wasn't on the CAN bus from our icon control. I was on the main CAN bus of the machine. And then I just started the procedure to flash the software. And of course, this controller, it was properly adjusted with cybersecurity, said there's something wrong. I shut down the complete machine. And it was shut it down completely. Unfortunately, late in the evening, because we were hitting in a traffic jam, and we just said, okay, we will make the upload and then go to the hotel. And the next day, we needed some service partner from this machine manufacturer to unlock the machine again. So in this case, I could say cybersecurity was working well, but the entire machine was
a bit too
dead.
well
Yes.
for the uptime of the machine. So you became your own hacker, and then you've come to the next point that's actually very interesting. For the operator, for the operation of the machine, to shut it down completely is very problematic. So can you describe to us this segmentation and how that helps to prevent the whole machine from being shut down, right?
One of the things that we try to do, and you can see it sort of in the architecture that's on the screen now, we try to separate the buses that are safety critical from the buses that maybe we would call dirty buses, where potentially the communications is exposed to the outside world, and we don't want access to the other communication buses from the buses that are exposed to the outside world. So we can create segmented systems where the access to those buses is much more controlled, and so that if there is an access issue, it doesn't completely disable the machine.
So that would prevent the situation that you had where the whole thing was shut down. And
I mean, the idea wasn't wrong because the machine did its best getting into a safe condition, and that was just shutting down and standing there.
Yeah.
But normally you should always consider to look if you have one entrance. You have only one door in your house normally. So there's only one entrance where somebody can get into. And this one, if you secure it at all and you don't have the possibility to spread into all the single CAN communications or controllers or functionalities, this is already a minor step for cybersecurity. That you have some check device that is already checking who is there, who is knocking on the door, who wants to get into the system, into the topology, and what he likes to do. This is the most important question. Is it a friendly guy or is it a thief that, for example, would like to steal or sabotage the machine? So,
is that where pen testing comes in?
Yeah,
to
that's
play?
right.
Yeah.
So one of the test parts that is involved in the software development process is looking at people who are actively trying to penetrate your system from a development standpoint, so that we can use penetration testing to understand if there's weaknesses in the software, and we can address those before we release the software to production. So pen testing is basically one of the tools that we use to reduce that likelihood, and would be identified during the TARA process.
It's putting on the hacker hat.
That's right.
Okay. So going back to the standards, do you think, a couple of questions, do you think OEMs will be ready on time? I think you touched upon that before. And if not, what are the main things that they can do in their efforts to reach these standards by December 27, I think it is?
Yeah, I think the concern is that many suppliers or maybe don't have a skilled team that's ready for things. Even some of the suppliers like ourselves maybe not ready for it. So there's a lot of components out there that just aren't ready. And I think the suppliers are going to need to use tools like the TAR analysis to understand where the greatest risks are, where the highest severity issues could come into play, and make sure they address those. I think it's nearly impossible that an OEM will be able to fully meet the requirements as defined in the time frame defined. But I think as long as they're moving towards those solutions, I think they can be a little bit more comfortable when they have to defend themselves from the cyber attacks.
Okay. Thank you so much for sharing your insights. Do we have any questions from the audience for our cybersecurity experts? Any experience that you've had that you'd like to share, or question you have for our experts? Nope. Okay. Well, Jason, Damian, thank you very much for this overview of software controls and its implications for productivity, for cybersecurity, and also how we need to be fit for the future coming up with the Cybersecurity Resilience Act.
Yeah, thank you for having us.
Thanks for being here.
Thanks.